What does the error code F1 mean in air conditioning units, and how to fix it? Let us start by saying that the meaning of the F1 code is not always the same. It varies between manufacturers, and even between models of the same brand. However, we will group its possible meanings based on several brands where most models coincide. The F1 code can appear when the indoor unit electronic controller detects an out-of-range electrical resistance in a temperature sensor. This can be due to an infinite electrical resistance value indicating an open circuit in the temperature sensor, an extremely low electrical resistance value indicating a short circuit in the temperature sensor, or an abnormal resistance reading when the temperature sensor is out of calibration. This fault occurs in the temperature sensor that measures the indoor air temperature of the conditioned space. This meaning is common in many models of the following brands: Friedrich, Amana, Train, Gree, Mabe, Sinclair, Lennox, Olimpo. However, in other brands that use an outdoor ambient temperature sensor located in the outdoor or condenser unit, the F1 code indicates a failure in that sensor. Some of the brands that identify this error in that way are Midea, Westinghouse, Voltas. For failures related to any temperature sensor, these are the recommended steps to try to solve the problem. 1. Turn off the unit and disconnect it from the electrical supply for several minutes. 2. Reconnect and turn it on to check if the error disappears. 3. If the error persists, turn off and disconnect the unit again. Locate the affected sensor according to the equipment brand and check the condition of the connection. Ensure it is not loose, dirty, or damaged. Then turn the unit back on to see if the error reappears. 4. If the code appears again, disconnect the sensor. Use a multimeter in the kilo-ohm scale to measure resistance by placing the probes on the sensor terminals in any order. 5. The reading must never be 0 because that would indicate a short circuit. 6. It must also not be infinite because that would suggest a broken or open sensor. 7. If a problem is detected, replace the sensor. 8. If the cause of the error is still not identified, compare the multimeter reading with the value specified in the equipment service manual for the corresponding temperature. If there is a discrepancy, the sensor must be replaced. Now, for other manufacturers, the F1 error code is related to failures in the outdoor unit, specifically in the IPM module or Intelligent Power Module, which is the component responsible for electrically powering the inverter compressor. Some of these brands are AUX, Rheem, Benelux. Some Voltas models: Hi, Oneida. To check the status of the IPM module, follow these recommendations. 1. Turn off the unit and disconnect it from the power supply. 2. Reconnect and turn it on. Check if the error reappears. If it does, verify with a multimeter the supply voltage from the electrical grid. If the voltage is unstable or out of range, consider using a voltage stabilizer. 3. If the problem persists, check if the outdoor coil is clean and ensure the fan is spinning correctly. Poor heat exchange in this area will increase refrigerant pressure, overloading both the compressor and the IPM electronic module. 4. If cleaning is required, make sure the equipment is completely disconnected from power. 5. If the error still appears, and with the unit completely disconnected, go to the inverter compressor. 6. Disconnect its power cable. With the multimeter in the ohm scale, measure resistance between the compressor terminals. The values must be practically equal between terminal pairs and never zero or infinite. 7. If abnormal values are found, the compressor may be faulty and forcing the IPM electronic module. 8. If everything seems fine and the issue is still not identified, proceed to inspect the IPM electronic module located on the outdoor control board. 9. We will now identify how the IPM electronic module powers the compressor. Follow these steps to correctly identify its pins. A. Ensure the control board is fully disconnected for several minutes. B. Identify the positive and negative poles of the electrolytic capacitors. C. With the multimeter in continuity mode, touch one capacitor terminal, and with the other probe find which pin of the IPM electronic module has continuity. The pin with continuity to the positive capacitor pole is the positive supply of the IPM electronic module. The pin with continuity to the negative capacitor pole is the negative supply of the IPM electronic module. D. Now identify the 3 pins of the IPM electronic module that have continuity with the compressor cable connector. With the multimeter in continuity mode, place one probe on one compressor cable terminal, and with the other probe find the corresponding IPM pin. E. Repeat the procedure for the second and third terminals. F. Once identified, test these 3 pins with the multimeter in diode mode. Place the negative probe on the positive supply pin of the IPM electronic module and keep it fixed. With the positive probe, test each of the 3 compressor pins. Each reading must be equal. If there are differences, the IPM electronic module is damaged. G. Now repeat the test but reverse the multimeter probes. Place the positive probe on the negative supply pin of the IPM electronic module and the negative probe on each of the compressor pins. Again, all readings must be identical. Any variation indicates that the IPM electronic module is defective. What should you do if your brand does not appear in this video? It is recommended to follow these steps. A. Start by checking the indoor unit temperature sensors and perform their diagnostics. B. Then verify the outdoor unit temperature sensors if your system has them. C. Clean the outdoor coil and the indoor air filter. D. For inverter units, focus on diagnosing the IPM electronic module.